A confirmation about the audio, please, guys. If you're able to hear me out perfectly well, kindly confirm the same. Thank you. Dead Sea and Sargasso Sea are same? Absolutely not. They are very different and situated in very different parts of the world. So, hello, a very warm good afternoon to all of you, and welcome to Baiju's Exam Prep IAS. Welcome to another weekend of geography, where today we shall be embarking upon some of the very important concepts in climatology. Now, in the last weekend, we discussed about the permanent wind system, the aspects of rainfall, different types of precipitation, cloud formation, as well as we had an introduction about the air masses and fronts as well. So this week, we start from the portion where we left off, that is the formation of the fronts. And then we shall be entering into the portion of different types of fronts, leading us to the formation of cyclones, the different types of cyclones that are present, temperate as well as tropical. We'll come to an understanding that which type of cyclone frequents our country and why is that the case. And then also, we shall be moving on into certain atmospheric phenomena such as jet streams, Enzo cycles, Indian Ocean dipole, Maran-Julian oscillation, before entering into the portion of Indian monsoon. Now, I presume that till now, whatever we have studied has been revised by all of you as well. So I presume that if we talk about the permanent wind system and the world climatic distribution, I hope and I presume most of us would have had a detailed clue and a detailed analysis and idea about that as well. So with that, we shall be taking up the concepts that we have discussed till now, and this weekend we shall be building up on all those particular concepts. Shubhoji, do we need to read about the detailed heat budget of Earth? No, you just need to have an idea. So the heat budget of Earth, that tells us the total amount of heat taken in and the total amount of heat given out. So that maintains a balance in terms of heat received on the surface, which doesn't allow the planet to get overheated or overcooled. So you just need to get an idea about what it is. You don't need to get into the depth of it. Okay? Now, having said that, let us initiate the discussion from the portion of fronts. Okay? How does air drainage protect plants from frost damage? Okay, so air drainage in the portion of temperature inversion and particularly in the portion of valley inversion, there in NCRT, it significantly jumbles up and it ends up confusing you. So that is why you would also have gotten confused there. What is air drainage? Air drainage means, if you think about the term, what is it? That air drains out, right? From some place or some region, air is able to drain out. So in conditions of valley inversion, when we had talked about the valley inversion, we had talked about the fact that in the case of narrow valleys, oftentimes you have very cold air which accumulates at the bottom region. Very cold air accumulates at the bottom, creating valley inversion, due to which the plants, they die due to frost damage. So this is observed in the case of narrow valleys with restricted and constricted air passage or air flow. Now, suppose you have a situation where a valley exists in such a way that there is an outlet for the air. The air can flow into the plains in this area. Now, in that case, the cold air won't be accumulated in the region of the valley anymore. The cold air will start to have a flow, meaning in this region now, you don't have the accumulation of cold air anymore. So, in those cases, let's suppose where you have multiple different mountains and valley structures. Okay? Let's suppose multiple different mountains and valley structures. If the air gets trapped in between them, it can cause frost damage. But if the air is finding a passage to flow, that is what is air drainage. Okay? Is that understood now? Okay, good. So there are few things and aspects in NCRT, and please understand, NCRT also has got some amount of mistakes. So when you study the book of NCRT, do it with your eyes and ears open. Don't readily believe whatever is written in the NCRT. NCRT has got mistakes in it. So whenever you find anything which defies a logic or your general logic, try to find out that what is the correct aspect of it. Having said that, please don't get entangled in the kind of false hope that everything is incorrect, because that also happens when the candidates, they start reading a book, and if someone has told them that some mistakes are there, every sentence would be taken with, or would be looked at with a kind of suspicion that I know better, NCRT doesn't know. It is not like that. Majority of the things are correct. Here and there, few nuances, they end up confusing you due to misprint, due to various errors that you can expect out of a any government-run agency. In a way, certain lines are omitted there. So that kind of mishaps and mistakes that are present in NCRT. So whenever you take a look at it, do it with your eyes and ears open. Having said that, majority of the things are correct. So I cannot overemphasize on that. So I hope that will be taken care of. Okay. Now, just a moment. So now we again reinitiate our discussion from the portion of fronts and the frontal formation. So when we talk about fronts or the formation of fronts, these are those places of transition where you have air masses of different properties when they tend to interact with each other. So whenever we talk about fronts or frontal movement, you will come across air masses of different properties. Let's suppose we have cold air on one part, warm air on the other side. So the transition zone, that is referred to as a front. Okay. So if I tell you, or if I ask you, what are the conditions required for the formation of a front? So the conditions required should be, properties of air should be different. Of air should be different. In the sense, when we say property, significant difference in temperature. Okay, significant difference in temperature should be in existence. Now here, when I say properties are different, significant difference in temperature, it is of the comparative air masses. Now the air masses should not also intermingle and gain a homogeneous property, because if that happens, there is no zone of transition left anymore. So there, air or air masses should retain individual properties. Okay? That is where we observe the case of frontal formation. The formation or the birth of a front, that is what is referred to as frontogenesis. So formation is referred to as frontogenesis. That is formation of a front. Okay? Now, where does it happen in general, under general circumstances? Under general circumstances, if you consider, let's say, any one of the hemispheres, let's consider the northern hemisphere for that matter. Now, under general circumstances, you have cold winds coming from the polar areas. What is the name of this wind which comes from the polar areas? Let me know. What are these winds referred to as? So, cold winds coming from the polar areas. Good, Shubhajit. And you have warm winds coming from the equatorial or from the tropical areas. Warm winds coming from the tropical areas. Now, let me ask you a certain set of questions here. Now, warm winds are coming from the tropical areas. These warm winds are westerlies, right? And these are polar easterlies. Now, let me ask you a set of questions here. Now, do you think that in this entire belt where these will converge, do you think that the winds will be moving with equivalent velocity and equivalent magnitude across that entire region where convergence is going to be observed? Or will there be a difference in terms of magnitude of wind movement across the same belt? What do you think? Very good. Beautiful. So, the normal logic tells us, if not the portion that we have studied earlier, even by normal logic, we can get an idea that across the planet, it is almost impossible to have the same momentum of the winds moving across a very large belt, across a very large area. That means what? That virtually means that in certain areas, the cold winds will come further to the south, and in certain areas, the warm winds will go further to the north. Isn't it? So, in the zone of transition, that won't be uniform. You might also have in certain area the condition where cold air is active. Cold air is active. You might have in certain region the condition where the warm westerlies, they are more active. Warm air is active. Now, sometimes what happens even in normal day-to-day life is, let's suppose you are going to appear for an examination, and that is your main battle, that I have to appear for the examination. But if the case of, let's say, examination center hall is in itself 45 kilometers away from your house, by the time that you manage to reach the exam hall, your energy is already gone, you are already drained out. So what will you perform in the exam hall? Many of us would have encountered that. Similarly, here also, by the time that the winds come to the zone of interaction, many of the times they lose their energy. In the sense that, let's say, cold air is coming from here, warm air is progressing from this region. Now, by the time the cold air comes here, let's suppose, it has lost all the energy. It is still there, but it doesn't have any energy to push on, and it finds itself at a front, where the warm air has also come in, but warm air also doesn't have any energy to push on. So in this case, neither the cold air will push nor the warm air will push. Both of them will lie static, right? So that is the condition where you have static air, no movement. Okay, it will lie static here. Now, if it lies static, but after some time, let's say it again gains some energy. Maybe the cold air gains some energy. So the cold air will push. Maybe the warm air gains energy. So the warm air will push. But as long as it is static, very slowly and steadily, the air molecules, they will start intermingling with each other across the warm and the cold air region. Suppose it lies in this stationary position or the static position for, let's say, 3 to 4 weeks, right? Almost around 21 to 25 days. If it lies in this position, the air will intermingle. The air will start mixing with each other. And that is when you have the front was a zone of transition. That is when the air intermingles, takes each other's property, that is what is referred to as the death of a front, or what is referred to as frontolysis. Frontolysis. That is death of a front. When does that happen? When you have air becomes homogeneous. Okay. Now, another question that I'll ask you from this portion is, if I tell you that this front formation is happening because of difference in temperature, I would be correct in a way. So then, as a follow-up question, if I ask you, during which season will you have a greater difference of temperature between the warmer air and cold air? Or in other words, during which season will you observe frequent frontal formation? During the summer months or during the winter months? What do you think? When is it that the air difference of air temperature will be greater? Summer or winter? Monsoon, my dear friend, is only a month restricted to India. Monsoon month is not observed across the globe. Okay. Majority of you have given the correct answer in this. So, front formation will be observed in greater frequency when you have a greater difference in temperature between the polar regions and the tropical regions. And that greater difference in temperature, as rightly pointed out by many of you, is observed especially during the winter months. Let us take a look at it with the help of example. Let's suppose we consider temperature difference. Temperature, winter, summer. Right? Poles, tropics. Now, during the winter months, in the polar region, what do you experience? You will experience that the temperature is anywhere around minus 40, minus 45, easy. The tropics, the temperature is low, but still roughly around 15 to 20 degrees Celsius. Whereas during the summer months, in the polar area, the temperature rises a bit. It is still in the negative territory, but it is around minus 10, minus 12, somewhere around that. So let's assume minus 15 degrees Celsius. And in the tropics, the temperature is roughly around how much? Roughly around 30 degrees Celsius, 32 degrees Celsius on an average I am talking about. So 30 degrees Celsius, isn't it? So here, what is the difference in temperature that you attain? During the winter month, the difference in temperature can be close to around 60 to 65 degrees Celsius. Difference in temperature can be 60 to 65 degrees Celsius. Whereas during the summer, on an average, now you might argue that you are saying that in tropics it is 30 degrees Celsius, but in my hometown it is already 40 degrees Celsius. I'm still talking about an average because even in polar areas, sometimes the temperature can rise significantly to -10, -5, -7, or sometimes it can drop to -20 as well. So here the difference in temperature is how much? By roughly around 45 to 50 degrees Celsius. So the difference in temperature of the tropical and the polar air is starker, is more significant during the winter season as compared to summer season. That is why we can always have a conclusion drawn out of it that frontal formation is more frequent and prominent, or frontogenesis is more frequent during winter months. Okay. So I hope frontogenesis and frontolysis is clear, right? I had one of you, Avni, didn't understand frontolysis. So Avni, understand this. When we say frontolysis, frontolysis means death of a front. What is a front? Front is a transition zone. So when is it that the transition zone won't be present anymore? If we say death of a front, means there is no transition zone anymore. So that will come into existence when, let's suppose, the air is in contact with each other for a longer duration, and over a period of time, each of the air masses, they start gaining the properties of each other. When they are consistently in contact, slowly and steadily, the cooler air will become warmer, warmer air will become cooler, at least in the boundary zone, and there is no distinct zone of transition anymore. That is the death of a front, and that is frontolysis. Okay? And what does the diagram convey? What does this diagram convey? This diagram conveys the formation of a front. Dinesh, in Baiju's test, there was a question where frontal formation exists in tropical areas, and that was right. They didn't say whether between tropical and poles or tropic and equator. Okay. Now you understand where the front will be formed. Okay. All the grudges that you are holding, drop it out somewhere. And now you think about it carefully where the fronts can be formed. Think about it that zone of formation, this zone of formation can sometimes move northwards as well. Sometimes it can move southwards as well. So the frontal formation can very much happen in the region of tropics during the winter months. But sometimes during the summer, it will be further pushed up. Why? Because during the summer, the warm air will be much more active. So that is why it completely varies in terms of its formation. Generally, you will observe that the frontal formation is happening in the mid latitude, around 35 to 65 degrees. That is where the frontal formation keeps on happening. I hope that is understood now. Okay. Now, then we come across to the different types of frontal formation. Depending upon how they are formed, we have different types of frontal formation. Stationary front, the name itself tells you. None of them are moving. Both of them are static where they are. They are not intermingling or mixing with each other. Then you have a cold front. In this case, the cold air is more active. Cold air is more active and pushes the warm air. When we say a warm front, so warm front is what? In this case, the warm air is more active. Air is more active. And then we have an occluded front. Occluded means what? What is the meaning of occlusion? It is an English term which is used in geography. It is not a geographical term being used in English. So what is the meaning of occlusion in general? Occlusion basically means that something is closing out, or the activity or the act of closing. That is occlusion. When you have closed something out from a region, that is occlusion. So this is basically one of the final stages in the development of front, and sometimes observed during the case of the development of a frontal cyclone or a temperate cyclone, not generally otherwise observed. So this is observed in very rare situations where the cold air surrounds the front from all sides and manages to completely close the front by lifting the warm air upwards. So this is not a general formation of a front. This is observed when cold air surrounds the warm air from all sides and lifts up the warm air. This is the act of closing of a front. We'll take a look at this, what this is. Okay, so let us start with the stationary front. A stationary front, as the name in itself tells you, is something which is stationary, which is not moving. So here, the same example, that by the time that you have reached the exam hall or the battlefield, you have lost all your energy, all your caliber that you had. So basically, you are lying still there. So sometimes it happens that in certain areas, the cold air, the warm air reach there, but none of them have enough energy or enough power to be pushing into each other's territory. So wherever they are, they lie completely static or stable. That is what is a stationary front. So here, this happens when two masses of air pushing against each other, but neither is powerful enough to move the other. So that is where the cold air and the warm air, that basically they are lying in front of each other. Now, after some time, few things can happen. Maybe the cold air region. Now, this cold air is being supplied from a high pressure area. Warm air is also being supplied from a high pressure area. So sometimes it might happen that the cold air might develop energy and it starts pushing on. Sometimes the reverse can happen. The warm air gains energy and starts pushing the cold air. Sometimes both of them can lie in front of each other, gain each other's property, and that can lead to frontolysis. If, let's say, there is no movement happening for 21 to 25 days consecutively, then after some time, frontolysis is going to happen. So when we say stationary front can lead to formation of cold or warm front, depending upon which air becomes active. And also, if no movement for 21 to 25 days can lead to frontolysis. Okay? It can eventually lead to the death of the front as well. Now let's suppose the cold air is active. The cold air starts pushing in. Now, when we say the cold air is active, that is what is a cold front. So it is an easy method to understand and in order to recall. Whenever cold air is active, cold front. Warm air is active, warm front. Now here, I'll take the example of with a piece of paper, right? Always the most complicated of the concepts are easily understood if you take a very simple example out of them. So here, let's suppose I take it with a piece of paper. Now here, suppose when we say that the cold air is pushing into a region of warm air, always understand that the cold air will have a very definite volume. A very definite volume. It will be compressed in a way because cold air particles are closer to each other. Now let's suppose you have a region which has got warm air. Now warm air has got a greater volume. Let's suppose this is indicated, this hand is indicating the warm air and this hand is indicating the cold air column. Now cold air is active. Cold air is pushing. So as the cold air is pushing ahead, what will it do to the warm air? The warm air will simply be riding above the cold air. So when the cold air pushes in into the region of the warm air, as this pushes in, the warm air is completely lifted upwards. So here, the cold air, after some time, will manage to get into this area. Will manage to get here. And as a result of that, the warm air is thrown upwards. In this region, imagine cold air is pushing in, whatever the warm air was, the warm air is immediately thrown upwards. Now, here, this is what is a cold front. Now, as the warm air is thrown upwards, what will happen to the warm air in terms of temperature? What will happen to temperature as the warm air is suddenly pushed up? The temperature will start falling. And as the temperature will start falling, there will be condensation which will happen. But how will the condensation happen? Condensation will happen across various heights as the air is continuously pushed up. Some condensation will happen here, some here, some here, some here. So you have a vertical development of condensates, and that leads to formation of a multi-layered cloud. What cloud type? Here you will observe formation of cumulonimbus. Cumulonimbus, cloud formation. Why? Because of vertical rise. Vertical rise of warm air. So what will be the climatic conditions or the weather conditions observed when you have cumulonimbus clouds? What kind of weather conditions are observed in general? Let me see. Rain will be there in stratus cloud as well. Rain will be there in the case of nimbostratus as well. So what will be the difference in terms of cumulonimbus? Very good. There will be thunder, lightning, and very heavy rainfall. So this will lead to violent weather condition. Weather condition. This will lead to rainfall or thunder, lightning, and very heavy rainfall. Now, by the way, in this area, in general, apply your logic. We have not discussed it till now, so don't get that fear of missing out. Apply your normal logical phenomena. In this area, what will be the condition of pressure on the ground surface? Will there be a high pressure created? Will there be a low pressure created? What do you think? What will be the condition on the ground in terms of pressure? Very good. Beautiful. Oh, okay. No issues. Think about it. So few of you are absolutely correct here. There will be a condition of low pressure created. Why do I say so? There will be a low pressure created in this region because in this region, what you are experiencing? You are experiencing a rise of air column in that region, regardless of why that air is rising, but the air is rising nonetheless. So in general, in these areas, you start experiencing low pressure due to rise of air. Is that understood? Let me know. Due to rise of air, ground experiences lower pressure. But cold air is also there. So what? In the subpolar low pressure belt, when we talk about the subpolar low pressure belt, remember we talked about that in 60 degrees you have cold air from the polar area coming in and warm air from the tropics coming in. Both of them converge, the air rises up, and that leads to formation of low pressure, subpolar low pressure belt, if you recall that. Now there you have a cold air which is coming, and still you have a creation of low pressure on the ground. So just the presence of cold air does not mean it will always lead to high pressure condition. That is why these are dynamically created low pressure regions, similar to the conditions around 30 degrees, which is dynamically created high pressure region. So here, why do I say that a low pressure will be created? Because think about it, if there is the cold air which is present, now if here you have the warm air, now it will exert some pressure. As the cold air rushes in, the warm air is pushed up, risen up. So some amount of that pressure loss will be compensated by the presence of cold air, but you have a rising air column in that region. So on the ground surface, whenever you have a rising air column, ground surface indicates the conditionalities of lower pressure. Okay? The air which is rising is cold. No, the air which is rising is generally a mixture of the two, but in most of the cases, it is warmer air which rises up. Cold air is stuck to the ground, is hugging the ground. It is a warmer air which is rising up. Okay? Now we come to the condition where the warm air is active. That is a warm front. Now, in this case, it is the warm air which is pushing ahead as compared to the colder air. So imagine a region where you have this cold air and the warm air is rushing in. Now this warm air, when it encounters the incline of the cold air, it will start to very slowly and steadily rise up the incline. Very slowly and steadily, it will rise up the incline. That is where it will create a kind of a warm front. Now it is different from the condition of the cold front that we just saw. In the case of the cold front, the warm air was violently being pushed upwards. Here, it is slowly and steadily climbing up. So this warm air, let's suppose this is the warm air. Let's suppose this is your cold air. So suppose you have the warm air and you have the cold air. Now, in this condition, when the warm air gets in contact with the cold air, that is where you will find that it starts losing temperature a bit. Here also, the temperature is lost. So, in this case, also there will be cloud formation. But the cloud formation will be gradual, spread over a horizontal area. That is why here you will find the formation of nimbostratus, altostratus, cirrostratus, cirrus at various different levels. you have the formation of various different types of clouds. So here you will observe cloud formation here, cloud formation to happen here, here, and so on. That is basically a gradient of cloud formation. Now, what will be the weather condition observed in this region? Weather condition observed in this area? Rain will be there, that is true. But what kind of detailed weather condition can you observe here? Okay, very good. You have moderate rainfall, continuous for a long duration, overcast conditions for a long period of time, lack of thunderstorms. Lack of thunderstorms. You can observe bouts of lightning here and there, but that will be very limited. Overcast means covered, the sky is covered with cloud cover. That is basically overcast conditions. Okay, so now that you have studied about clouds, just the answer that it will rain won't suffice. I want you to dig a bit deeper and to be a bit more precise that why rainfall is happening, what kind of rainfall is happening, how long is it supposed to rain if you have certain set of clouds. So that kind of finesse needs to be acquired by you slowly and steadily as we progress. Okay? Vineet, my dear friend, you have a different batch for Hindi BHLP. So I think you have joined a wrong batch in that case. This is going to be an English method of communication. Now, is that understood about warm front and cold front, or any doubts in that? Cold front, Sai Babu, when we say cold front, in that case, it is the cold air which starts pushing in, due to which the warm air is suddenly and violently pushed upwards, due to which you have cumulonimbus cloud formation, due to which you have violent bouts of rainfall, very heavy rainfall, along with thunder and lightning. Okay? Yes. Now, in this case, what do you think will be the pressure condition on the ground surface here? In general, will there be a low pressure or high pressure? Good. Oh. So most of you are correct. In this, generally, you have a kind of a low pressure. Again, why? Because here also you have a rise of air. Always remember, whenever you have a rising air column, the pressure conditions on the ground, that tends to reduce. Okay, so that is why here also in general, you will observe a lower pressure. I'm not saying the most absolute low pressure across the planet. I'm not saying it will be very intense low pressure. Nonetheless, the pressure will be reduced. Okay, so that is basically the condition of a warm front. Okay, so if you have to think about the difference between them, understand cold front, cold air is active, warm front, warm air is active. Cold front, the warm air is vertically pushed upwards. Warm front, it horizontally moves ahead. Cold front, cumulonimbus cloud. Warm front, because it horizontally moves, nimbostratus, altostratus, cirrostratus, and so on. Cold front, violent rainfall with thunder and lightning. Warm front, moderate rainfall without much thunderstorms. Okay? I hope that is understood by Gobind, Dola Gobind. You had this question. Now we come to one of the complicated, slightly complicated fronts, and that is the occluded front. Occluded basically means the act of closing down. Something when it starts to close down. That is what is occlusion, right? So generally you will observe that occluded front is formed Finally, let's say the fronts are active. Occluded front will be the final stage before frontolysis. When the front formation is diluted, the front is closed down. So let me write a few things about occluded front and then we'll get into the details of it. Don't worry. So here, generally observed in the final stages of frontal development. The image that you are seeing, this image is the image of the stages of a temperate cyclone. The image on your screen, that is not only for an occluded front, that is for the various stages of a temperate cyclone. It helps you understand about how frontal development can happen sometimes, right? So here, eventually leads to frontolysis. Why? As the front is closed. Now, how is the front closed? Cold air surrounds the front from all sides, meaning no warm air on the surface. So the front is closed. Now let us understand this. Even though this image is of a temperate cyclone, but let's assume that a front develops like this, where if I tell you and if I walk you through the various different images, in the first image, you will observe that the cold air is present here, the warm air is present here. Now, I want all of you to be active. Even though the front can be stationary, but I want you to be active when you respond, because if you understand this particular portion, temperate cyclones will be very easy to follow. So the first image that you see, what kind of front do you think is represented there? The cold air is present, the warm air is present, but none of them are moving into each other's territory. What kind of front do you think is present? Very good. You have the stationary or the static front which is there. Now, observe how the front starts to intensify. Observe here. The warm air pushes into the colder region and vice versa. So the front starts to intensify. Now here you have to observe this particular image on the side. The reddish tinge in the image indicates warm air and the bluish tinge indicates the presence of cold air. So here you will observe that on the ground surface, what is the pressure condition formed? We do know about the pressure condition in both these cases. So here on the ground surface, you have a low pressure formed. Regardless of whether the cold air is active or the warm air is active, in either ways, it is the air which is rising up. Now that low pressure means more cold air as well as warm air, they will also come in. But always understand that cold air will always stick to the ground surface. It will always hug the ground surface. Why? That is because it is heavier, right? Some part of the cold air eventually also rises up due to convergence, but significant portion, majority of it, hugs the ground surface. Now, as it hugs the ground surface, it will start engulfing the entire frontal region. From all sides, it will engulf the frontal region because it is attracted towards that low pressure eventually. And then finally, observe that the frontal formation, this was the front initially. That front got modified into a skewed portion. that further skewed itself. Then it further got distorted, right? Observe finally, the cold air has surrounded the front from all different sides. In this image, observe that the cold air has surrounded the warm air from all different sides. And finally, the warm air is lifted upwards. So on the ground surface, along the region of the front, you don't have any warm air present. All around it, you have cold air. So around a region, if you have only one kind of air which is present and no distinct temperature properties which are present in other air mass, obviously, we don't have a front anymore. Because for the existence of a front, you do require, or you are required to have two different air masses indicating different temperatures. But in this case, you have only the cold air. Now, how did we arrive at this stage where we only have cold air? That is, as the front formation got intensified, the colder air being heavier would stick to the ground. So regardless of the cold front or the warm front, it is the cold air on the ground surface. It starts engulfing that low pressure, completely surrounding it. Now here, if you observe the image on the bottom, this particular image, if you can observe. So here you will observe, initially the frontal formation gets distorted. Observe how the cold air tries to surround it from all different sides, and eventually the front is closed down with one low pressure cell getting separated. So that is what is occlusion. The occlusion of a front is when a front which develops, let's say like this, eventually develops like this, eventually that entire front closes down. That is what is occlusion or occluded front. After this, frontolysis is generally observed. Okay? Now, with that, we approach the portion of cyclones. Now here, when we come to the area of cyclones, we shall be talking about two different types of cyclones, temperate and tropical. Now, what are cyclones first of all? When we talk about cyclones in general, cyclones mean what? Cyclones are intense low pressure regions, intense small low pressure areas which are created, which develop a circular motion of the wind around it. Just the existence of a low pressure is not referred to as a cyclone. The low pressure should be intense enough that around it you have the development of a circulation, right? So when we say cyclonic circulation, first of all, understand that you have two kinds of conditions, cyclonic and anticyclonic circulations. Cyclonic circulations are created around intense low pressure, not just an average low pressure. Very intense low pressure is called a cyclonic circulation. So understand that wherever that particular cyclonic region or center is formed, around that a circulation has to exist. And what particular force will give rise to a circulation or a movement of air in a circular manner? Which particular force will be responsible? Very good, Pranay. It is the Coriolis force. The Coriolis force will bend the winds in such a direction that basically the winds end up taking a circular route. So basically, wind circulation around a low pressure. So observe this particular low pressure here. Now, around this low pressure, the wind is coming in, and because it is a low pressure means the wind has to rise up. Low pressure is associated with rising air column. High pressure is associated with a sinking air column. So the wind rises up in a circular or a spiral manner if you observe. In a circular or a spiral manner, if you will observe here. Isn't it? So as the wind moves up in a circular or a spiral manner, eventually you will observe that the wind loses temperature, air loses temperature, forms clouds, brings you rainfall. So cyclonic circulations are extreme low pressure circulations or circulation is created by extreme low pressure where winds rush in from all direction, they start taking in a kind of a circular motion above. For example, when we say the circulation is observed, so what kind of circulation? Let us understand that. So when taken a look from space, this is how the cyclone appears from the top. So here, basically, let's suppose we have a low pressure in the northern hemisphere. So around this, the winds will rush in, the winds will converge from all different directions. Now, as the winds rush in from all different directions, now, because we are in northern hemisphere, due to Coriolis force, the winds will bend to the right. So the winds will bend to the right. All the winds will bend to the right. So let's say I ask one of you to stand at the center of low pressure. And I ask you to report that from your point of view, what is the direction of the wind that you are able to observe? You'll basically be able to observe a wind movement in this direction somewhat. Now, what is this? This is a kind of an anti-clockwise. So here you have anti-clockwise circulation. Whereas if we are, let's say, in the southern hemisphere, in the region of southern hemisphere, let's assume you have that low pressure. Winds are coming in. Now, due to Coriolis force, here also you will experience some bending. But that bending will be in which direction? It will be in leftward direction. All the bending will be in leftward direction. So here, if I ask you the same question, that stand here and report the direction of the wind. So you will observe the wind is moving here in a clockwise circulation, right? So here you will observe a kind of a clockwise circulation. So what does that mean? That basically means that depending upon which hemisphere we are in, the direction of wind movement around a low pressure, that shall vary. And same is the case with the high pressure centers that are anticyclones as well. The opposite of cyclonic circulation is anticyclone. Now, anticyclone means a creation of a very high pressure. So around high pressure, what is the condition of air that we get? We get sinking air. Observe this. This is a region of high pressure. Air is sinking. Now, as the air is sinking, it will originate from here and move in all different directions. But there also, it will be impacted by the Coriolis force and the bending initiated. So while a cyclone from above appears to be something very cloudy, an anticyclone from above is marked by a distinct lack of cloud cover. No cloud cover. Why? Because you have sinking air column. For cloud cover, always you need air to be rising up. So this is the region of no cloud cover or a region of high pressure. Okay, so if sometimes you get a look into the sky and you observe all around, there's a distinct cloud cover and a large gap, that means this is a region of sinking air. The air is sinking in that region. Air can sink down because of various conditions. Air can sink down because it becomes very cold, for example. Air can sink down if the ground surface becomes very cold. So air can sink down because of various reasons. So here also, the circulation initiated by an anticyclone is going to be different in the northern and the southern hemisphere. How? So for example, if we talk about, let's say, the northern hemisphere, This is the anticyclone, means absolute high pressure. And from high pressure, the winds will originate and they will be moving in different directions. Wherever you have high pressure means oversupply, and winds will originate, move in different directions. But as they are moving in different directions, they will be impacted by the Coriolis force. So the wind will originate, move in different direction, but it will be impacted, or the bending will be initiated or impacted by the Coriolis force. So this will bend to the right in the northern hemisphere. This will also bend to the right. This will also bend to the right. This will also bend to the right. So overall, what is the circulation? A kind of a clockwise. So in northern hemisphere, you come across clockwise circulation. What about the southern hemisphere? In the southern hemisphere, you will observe something very similar, but in a different direction. So here the winds will originate, bend to the left, bend to the left, bend to the left, and bend to the left. So overall, the circulation around that high pressure will be anti-clockwise. So here you have anti-clockwise circulation. Always remember, rising air will bring you rainfall because rising air will lose its temperature, cool down, condense, form clouds. Sinking air will never bring you rainfall because sinking air eventually warms up. For cloud formation, you need cooler conditions and condensation to happen. So sinking air will never bring rainfall. Rising air will bring you rainfall. Now, around the cyclones, when we talk about the cyclonic conditions, these are very intense low pressure systems. And when you have very intense low pressure systems, means air will rush in from all various directions, all different directions, the air will rush in. It will rise up, and that is when very intense rainfall, very significantly heavy rainfall will be observed along with thunder and lightning. So that is why cyclonic circulations, they are generally observed or followed by these kinds of weather conditions. So here we start with, first of all, the temperate cyclone, and then we will venture into the area of tropical cyclone. In India, we get impacted by tropical cyclone. So that is why generally in the examination, you will find that questions from tropical cyclones are asked in greater frequency, but nonetheless, temperate cyclone should also be known. Now, first of all, starting with the area where you observe this area. It is in mid-latitudes, mid-latitude region. Mid-latitude region means in the region between 35 to 65 degrees or 60 degrees. Then, here, reason for formation. For formation. Cyclone means there has to be an intense low pressure, but this is in temperate region. So the reason for formation is development of very intense low pressure. Now, why is there a development of very intense low pressure? Significant frontal development whenever you have a significant frontal development leading to a massive rise in air column. So, massive rise in air column. So that is when you have a very intense low pressure. So that means for the formation of a temperate cyclone, you do need a front, but does not mean that every front will lead to a temperate cyclone. I will repeat this. For formation of a temperate cyclone, you need the frontal development to intensify. So for the formation of a temperate cyclone, you necessarily need the formation of a front. No temperate cyclone can develop without a frontal formation. But the reverse of it is not true. That means that every frontal formation will not lead to the development of temperate cyclone in general. I will write it down as well so that you don't get confused eventually. So, front is required. Frontal formation is necessary for temperate cyclone. But, and that is a big but, every front does not develop into a cyclone. Just like you need to be an aspirant to become a civil servant in general to clear the exam, but does not mean that every aspirant will become an IAS officer. So something of that category. You know, these temperate cyclones, these are observed across a very large area, very large, in the sense that observe the satellite images of the cloud cover. Now, this cloud cover, the radius of the entire disturbance, that can sometimes, or rather the diameter of it, can sometimes range to around 750 to around 1,000 kilometers in terms of its width. Now think about it. Why is it that it develops over such a large area? Low pressure, after all, would be formed over a smaller region. Why is it that we observe a cloud cover over such a large area? The answer is very simple here. That is because the formation of clouds in this case, or the formation of the entire low pressure disturbance, is happening over a front. And fronts are very large. Fronts oftentimes can span for hundreds of kilometers. So if you have a rising air column across the entirety of a front, that means the disturbance formed as a consequence of it will also be very, very large. So aerial coverage is very large. Why? As the disturbance is formed over a front. Okay? The disturbance is formed over a front, hence the aerial coverage is going to be very, very large. Now, here, the low pressure which is created, this intense low pressure, that is what is leading to a cyclone. Any cyclonic formation will always be created due to this low pressure. Now, this low pressure, is it thermal in nature? Is it dynamic in nature? What do you think? This intense low pressure, is it thermal in nature or is it dynamic in nature in general conditions? Very good. Very good. So, majority of you are absolutely correct here. This low pressure is dynamic in nature. It is created across a front. We have seen across a front, why will the air rise? And it is that rise of air which creates that low pressure or high pressure. It is because of the condition of warm air movement or the cold air movement. So generally it is dynamic in nature. Sometimes its power is magnified when the thermal conditions they intermingle with that. For example, when you read about newspapers or read about the various cyclonic events which hit, let's say, the northern part of Europe, around the region of Great Britain, or around the region, let's say, of United States, the western and the eastern, northern part of United States, obviously. So there, you would observe suddenly that you will hear about the reports that a very strong cyclone has hit that, leading to intense amount of rainfall, flooding, many people dead, many people getting displaced. Now, many of the times, while you follow these news headlines, you get an understanding that sometimes this cyclone intensifies as it moves. So that is when sometimes the thermal conditions, they intermingle with the dynamic conditions. Whatever might happen, as intense as the low pressure is, greater will be the winds moving towards it, and greater will be the winds rising. So greater will be the amount of rainfall, wind movement, etc. So stronger the low pressure, stronger will be the impact of the cyclone. Always remember that. Now, here, in which season do you think this cyclone will be very frequent? In the summer season or in the winter season? Good. Pranay. Shubhajit, correct. Anshu, correct. Dinesh, Annie, correct. Nitin, you are correct. Obviously, you have only two options. So, good. Vishal also. So, always understand that why does this cyclone formation take place? It is because the front intensifying itself. Now, frontogenesis is going to be much more frequent in winter season. So that is why cyclones frequent during winter season. Okay? Now, also an associated, a common sense kind of a question, even though those are the hardest to answer to. When you think about this cyclone formation, where do you think this will be a more frequent phenomenon, northern hemisphere or southern hemisphere? Where do you think? Very good. Generally, you will observe that in the northern hemisphere, you have very frequent change in temperature of the air masses due to influence of land areas. So that is why many of the times the frontal formation intensifies. Understand, not the mere development of front will not lead to the generation of cyclone, but the intensification of that front. So that is why in the northern hemisphere, that intensification is very frequent because of the presence of the air masses. Okay. Now, the temperate cyclone is also referred to as a mid-latitude depression. Depression refers to a low-pressure region. Extratropical cyclone, that is because it is occurring beyond the tropics. Frontal depression, why? Because it is occurring across a front. Or a wave cyclone. Why is it referred to as a wave cyclone? Because generally fronts appear in a wavy format. We have seen it earlier. Fronts, they don't appear as a straight line. They generally appear as a wavy curvature line. That is why a wave cyclone. Now, temperate cyclones are active above mid-latitude regions between 35 degrees to 65 degrees latitude in both the hemisphere. Now, the direction of movement. Movement of what? Movement of the cloud conditions, movement of the cloud cover, the disturbance, everything. Now, the general direction of movement is from west to east. What do you think might be the reason that the entire disturbance along with the cloud cover, everything is moving from west to east? Beautiful. That is because in the region where they are formed, you have the presence of a permanent wind system. And what are the permanent winds? The permanent winds are westerlies. Very good. So, due to presence of westerlies, due to presence of westerlies in the region. That is why the entire disturbance appears to be moving from west to east and is more pronounced during the winter season, because that is when frontogenesis is more common. Why? Because the difference in air temperature is more prominent. This is when frontogenesis is common or is more frequent. Now, it is along these latitudes that the polar and the tropical air masses meet. They form fronts, and when they are more frequent, again, I will reiterate, frontal formation is necessary for a temperate cyclone, but does not mean every front will develop into a cyclone. Every front does not develop into a cyclone. Okay? So now we take a look at the various different stages of the cyclonic development. Now listen to these stages very carefully, even though if you have understood the process of formation of a front, this is a mere follow-on procedure to this. But generally, candidates, they find the understanding of cyclones very difficult, because when we read the newspaper articles, newspaper headlines, let's say you are searching for cyclones and its information in a newspaper headline or anywhere, what the newspaper headline appears to look like is low pressure region has developed over XYZ. Observe it. Nowadays, the newspaper headlines will be sprinkling the news with cyclone Mocha, which is developing in Bay of Bengal. That is a tropical cyclone. Now, the newspaper headlines will appear something like low pressure region has developed over the region XYZ. Strong winds are coming. And after that, this has caused destruction here, here, here. People have been evacuated here, here, here. Rainfall here, here, here. Flooding here, here, here. So you don't get any idea that why that has developed or how has it intensified, if at all. So that is why follow the various different stages. If the question appears in the examination, be very confident to represent the various stages as well. So starting with the first stage, or the stationary and the beginning phase. Now, the first stage for anything starts with what? The air coming to that area. So the first stage is the stationary phase. In this phase, you have the formation of a stationary front. Formation of a stationary front. So the air has come to that area, but neither the cold air has got enough power to venture into warm air territory, nor the warm air has got enough power to venture into the other region. But slowly and steadily, let's suppose the front intensifies. Because other option can be frontolysis, right? Other option can be cold front, warm front, or frontolysis. So let's assume that the front develops. Front develops means warm cold air will start pushing into the region of the warm air, and vice versa. Warm air will start pushing into the region of a cold air. Now, if that happens, what is the outcome? So observe, the front starts getting distorted because the cold air ventures into the region of warm air and vice versa. Now, at this stage, when you have beginning of a young adult, at this stage, you will have simultaneous processes where the cold air ventures into the warmer air and warm air ventures into the region of the colder air. So, this stage is observed by initiation of two fronts very close to each other. Why? So, cold air pushes in, that leads to formation of a cold front, and also in the other area, warm air will also push in. Here the warm air is also pushing in. So, warm air moves towards colder air region. That gives rise to warm front. Okay. So, from one area, the cold air starts coming in. And very nearby to that region, the warm air starts venturing into the region of the cold air. So, simultaneously, cold front and warm fronts are formed. Now, in this area, in this entire region, let's suppose you are the individual who is going to report the air movement in that area. In general, what can you say about the air, property of air? Will the air rise up in this region, or will the air sink down in this area, or will the air be as it is? What do you think will be the condition of the air? Invariably so. It will rise up. Why? Because if you talk about the cold front, the warm air rises up almost vertically. If you talk about a warm front, warm air rises up, but this time not vertically, but in a kind of an inclined manner, in a gradual manner. Regardless of how it rises up, in both these cases, the air will rise up, isn't it? So here, in both these regions lead to rise of air. So both these will lead to significant rise of air. And when you have a rise of air parcel, what pressure conditions are created on the ground? We have talked about it. This creates low pressure. Now, when a low pressure is created on the ground, means what? It will attract more winds from all directions. From colder areas, it will attract cold air and cold wind. And from warmer areas, it will attract warmer air and warm winds. So when both of them will be attracted, observe, then you have the development of a mature phase. So in the case of the mature phase, here you have a cold front, the cold air is active. Here you have the warm front, the warm air is active. Here you have a low pressure, because all around it, the air is rising up, right? So here you have the formation of warm front. Observe, above the warm front, the air is rising in a gradual manner. Above the cold front, it will rise in a vertical manner. Cold front. Now, as the air rises up, Do you think the air will experience a kind of a Coriolis force induced circular motion, or the air will rise up like a disciplined student without any deviation? What do you think will be the movement of air? Will the air rise up experiencing Coriolis? Will Coriolis force be active on the rising air, or rising air will rise up in a straight manner without Coriolis force? Good. So, the air as it is rising up, it will experience a kind of a Coriolis force as well, right? So Coriolis force is a reality that you cannot ignore in that case. So as the air rises up from both these areas, from both these fronts, observe you have a cold front. This might also spread across tens and even 100 kilometers sometimes. And this can also spread across, let's say, 50, 70, or 100 kilometers. So over that entire larger area, air is rising up, forming a large circulation. So in this case, a circulation will be observed. Okay, so here, circulation. First of all, distinct low pressure region develops. A very distinct low pressure region develops. Now, here, air rises up and develops a cyclonic circulation. Weather observed across the warm front and weather observed across the cold front, will it be similar or will it be different? What do we think? The weather observed across the warm front and cold front, will it be similar or will it be different? Very different. It will be very different. So simultaneously, different weather conditions are observed across both warm front and cold front. Now, what type of different weather conditions will be observed? Warm front, moderate rain, and prolonged rain. Right? Here you have nimbostratus clouds, which are dominant. Nimbostratus as the dominant cloud. Whereas when we talk about cold front, heavy rain, thunderstorms, and cumulonimbus clouds. Lightning also, and you have cumulonimbus. So this is the mature stage of the cyclone. Now, as this cyclonic circulation continues, eventually it is a low pressure. Low pressure means more cold air will be driven here and more warm air will also be attracted here. But the warm air which is attracted, that will keep on pushing across the warm front. And as a result of that, what will happen? The warm air, when it attacks the across a warm front, it does not manage to push the cold air back. It simply manages to rise up. So more warm air is coming, more of it is rising up. So continuously more rising air means what? You have further intensification of the low pressure. So more warm air is being driven from the tropical area, more of them is rising up. Meanwhile, the cold air which is coming in, that cold air hugging the ground surface starts attacking the region of low pressure, lifting any other air around that region, and slowly and steadily that low pressure is surrounded by the cold air. And this is where the front begins to close down. Here you have a very distinct cold front and a very distinct development of a warm front as well. So this is where front begins to close. Begins to close down. Okay? Here again, you will observe the occurrence of different weather conditions across the warm front and the cold front. A distinct cold front and warm front. Eventually, observe that all around it, the cold air is surrounding it. Eventually, you have occlusion or the dissipation. Now, why do we say this is the dissipation phase of the cyclone? That is because eventually the front is closing down on the ground. Now, here, if the front is closing down, means there is no warm or cold front existent in that region. So that means this is a kind of a dissipation of a front or a frontolysis. So why does this happen? When does this happen? So when you have cold air, when it completely surrounds the ground, the frontal region, frontolysis occurs, and when you have occurrence of frontolysis means cyclonic circulation dissipates or ends. So think about it. Again, taking the help of a piece of paper, let's suppose here you have the cold air, the kind of a cold front. Now, slowly and steadily, what it means is, if let's suppose this is the low pressure region, from all around it, the cold air completely surrounds that front. So on the base, the front is completely closed, and whatever warm air was present, that warm air is now lifted up. So no warm air is present across the region of that front. Why? Because warm air has been consistently being lifted up, whether it was a warm front or a cold front, it is the warm air which is being pushed up. So as the cold air completely engulfs the ground region, the front will come to an end. So that will lead to the death of the front or frontolysis, which is what leads to the dissipation of the cyclone as well. Okay, so overall, if you have to recap it, the entire process. So it starts first of all with the stationary front, the cold air and the warm air coming close to each other. Now, each of them can start moving into each other's territory, leading to the simultaneous formation of a cold front as well as a warm front. Now, in both these areas, the warm air is rising up. Some amount of cold air sometimes also rises up, but generally the warm air is being pushed upwards. That virtually means that in this area, there is a rising air column in significant proportion. That means a very intense low pressure. Now, around that intense low pressure, you will observe that you have significant amount of rainfall which is caused because more air is dragged in from both colder and the warmer regions. So that virtually means that you have a cold front, a warm front which is created. Both of them cause significant amount of rainfall, but in different methods and in different types of cloud formation. Eventually, the warm air continues to get lifted upwards and cold air hugs the ground surface. That is when the front starts to close down. Eventually, the front will completely close down, and that is when occlusion is observed, or the dissipation of the front and dissipation of cyclone is observed. So that is the development and the end of a temperate cyclone. I hope we have understood. Any issues up till this point of time? Let me know. Or if we have understood, let me know that as well. Understood? Good. Okay. Beginning of occlusion stage, not understood. This is when slowly and steadily the front, as you can see, initially the front would be somewhat like this. Slowly and steadily, the shape will never remain like this. The shape will get distorted as the cold air at the bottom that will start hugging in. So let's suppose this is the low pressure. Warm air starts to rise up from this region. Warm air starts to rise up. Now, meanwhile, because it is low pressure, means warm air is already being attracted. Cold air will also be attracted. Now, cold air, when it is attracted, it will start pushing through this region. Slowly and steadily, this will become like this. Cold air will push in from here as well. Slowly and steadily, it will become like this. So it will begin to get deformed. So that is the beginning of occlusion. That means the front, which was very open initially, that front is closing down. That is stage 4. And stage 3, basically, Sai Babu, is when you have the full-fledged development of a cold and a warm front. That is where you have the development of a low pressure. That is where significant amount of different weather conditions across both these areas are observed. Do we can say that all cyclone moves towards equator a bit or not? No, we cannot say that. This is same as occluded front, this one. So, Yera, this stage 4 is the beginning of occlusion. Occlusion is when the front has completely closed down. This is the beginning of occlusion, that it has still not completely closed down. Chetan, why a nimbus cloud formed and not cumulonimbus? Cumulonimbus is formed across a cold front. Why is cumulonimbus formed? When you have condensation happening simultaneously at different heights. So that is when the warm air is pushed suddenly and violently upwards. So that is why, remember, during hailstorms, during cloudbursts, whenever you have a sudden vertical movement, that is cumulonimbus. So across a cold front, cumulonimbus is formed. Across a warm front, generally, because the rise is very gradual, so you have layering of clouds. So stratus types of clouds are generally created. Okay. Stages 3rd, we have complete development of cold and warm front. Yes, Aarti. And Shubhajit, after stage 5, the cyclone gets dissipated, yes, and destroyed. Then no cyclonic existence is observed. Late occlusion in what way? As in, late occlusion is the closing of the front. Vivek, there you don't have, see, this is the initiation of occlusion. This is the final stages of occlusion. Occlusion is the act of closing down. So when we say late occlusion, it is the closing down of the front, where the front has finally closed down. But it is not going to close down in a click. It is going to take some stages. It is going to take some time. So that is why in the initial stages, observe that the front is closing down ever so slightly. So, and finally, when the front is closed, that is what is or the referred to as occlusion or late occlusion. Is that clear, Vivek? Or is there a doubt which resembles? Yes, Pranay, cold winds like blizzard, they will impact temperate cyclones. Sometimes these will lead to creation or formation of occlusion much earlier. Generally, temperate cyclones, whatever destruction they will cause, they will end up causing in stage 3 and 4. That is when majority of the destruction caused is observed. Okay. Now, sometimes what happens is that when you observe the cyclonic development or the development of a temperate cyclone, generally you are able to predict that this will be the wind velocity, this will be the condition of the low pressure, that will be the condition of the direction of the wind movement, and so on. But sometimes what happens, suddenly the low pressure tends to intensify. And low pressure intensifies. Remember, I told you that sometimes it happens that the dynamic low pressure interferes with the thermal heating of a region. So sometimes a region can lose pressure very fast, very significantly. It can be purely because of dynamic reasons also. But whenever you have the sudden intensification of a cyclone, where at the region of the low pressure, the pressure drops by around 24 millibars and more within one day, then the cyclone suddenly intensifies, significantly becomes much more destructive, and that is what is referred to as a bomb cyclone. So, what is a bomb cyclone? Under normal cyclonic formation, a normal cyclonic formation is being observed. But suddenly, within one day, the low pressure has dropped by 24 millibar or more in one day. So that means if the low pressure has suddenly dropped, means what? Sudden drop in low pressure. If the low pressure has suddenly dropped, means winds will be stronger, means rainfall is heavier, more winds are coming in, rainfall will be heavier, much more cloud formation. Overall, cyclone or cyclonic circulation is much stronger, intense. So that is what is referred to as a bomb cyclone. And the formation of this is what is referred to as bombogenesis or explosive cyclogenesis. That is a very rapid intensification and a very rapid development of cyclone. That is what is bombogenesis or explosive cyclogenesis. Generally observed across tropical temperate cyclones. Generally observed across temperate cyclones. Okay, so that is your bomb cyclone. You come across, if you follow newspapers and news headlines regularly, which I hope, which I plead, and which I request you to do it. So basically, sometimes you have the sudden intensification where, let's say, a cyclone. Take the case of at one point of time you had cyclone Katrina, which was about to hit the eastern coast of United States. Suddenly, it intensified in nature, and That is that phenomena of intensification, that is bomb cyclone. Okay, right? So that is basically the aspect of temperate cyclone. Now we move on to the cyclones which influence us very prominently and very frequently on an annual basis. That is the tropical cyclone. But we'll take a look at it after the break. Okay, so how long a break do we need? Because at 3 we will have lunch as well. For 40 minutes, that break will be there. So let's take a break of around 10 minutes. 10 minutes should suffice. Okay, break of 10 minutes, and we'll be back after 10 minutes. And then we will carry on with tropical cyclones. A confirmation about the audio, please. If you're able to hear me out perfectly well, kindly confirm the same. If the audio is available, thank you. So now we come to the portion of tropical cyclones. Now these tropical cyclones, they are very destructive, very devastating. And also, when you hear about the term cyclone, the immediate picture that comes to your mind, the immediate image that comes to your mind of very strong winds, flooding in the coastal areas, lot of destruction, that is generally associated with tropical cyclones. Now, in the case of tropical cyclones, the region is defined by the name itself. So it is formed in the tropical region. Now, it is always developed over the water bodies. Why it develops over the water bodies, we will come to it. But it always develops generally over the water bodies in itself. So generally in the tropical areas above the water bodies. Now, again, I would like to reiterate, by water bodies, I do not mean that I had kept a bucket of water in my backyard and a cyclone has developed, or there is a pond in my backyard, a cyclone has not developed. You had said in tropical regions over water bodies, or there is a river moving nearby my region. No. Water bodies here refer to oceans and seas generally. So in the seas and the oceans in the tropical areas, that is where you have the formation of tropical cyclone. But around the region of equator, after all, equator also comes in the tropical area. Around the region of equator, you find an absence of cyclone. And why is that? Because at the region of equator, we do not have any Coriolis force. So Coriolis force is very essential to gain a circular motion of the wind pattern. So if the Coriolis force is absent, you don't have a development of a circular motion at all. So that is why in the entirety of the tropical areas, except equator, that is around 5° north to 5° south, you don't observe any cyclonic formation. Why? Because of lack of Coriolis force. A significant lack of Coriolis force. Now, this cyclonic development, in the earlier case of temperate cyclone, we had seen that you had a dynamic low pressure created. In this region, you have the development of low pressure due to thermal conditions. So, thermal low pressure development. What will be the general direction of movement of this entire cyclonic disturbance? The general direction of movement is observed from east to west. General direction of movement general direction of movement is east to west. And that is because of the impact of the trade winds. Due to trade winds. Okay? That is the general direction of movement of the entire cyclonic disturbance. Anti-clockwise. So Vivek, what you are referring to as anti-clockwise or clockwise circulation, that will be the circulation of air in this particular region itself. But this entire disturbance will also end up moving, right? So that is why that entire movement is in general east to west. However, there are certain discrepancies here also, where you will observe sometimes a cyclonic disturbance develops here in the region of Arabian Sea, and it hits the region of Maharashtra and Gujarat coastline. And as the recent cyclonic development is happening, if you are following the news headlines, as the recent cyclonic developments are happening across the region of Bay of Bengal, they are well on their way to hit the West Bengal coastline. So that kind of discrepancy is there sometimes, which is prevalent, but it is because of different reason altogether. We will take a look at it once we understand the entire process of cyclonic or tropical cyclone development. So here, when we take a look at it, so tropical cyclones, these are violent storms that originate over oceans in tropical areas, and they are known by different names. The phenomena is the same, but they are known by different names. If the same phenomena occurs in the region of northern part of Indian Ocean, it is referred to as a cyclone. If it is observed in the region of Atlantic, it is referred to as a hurricane. If it is observed in the region of Western Pacific and South China Sea, it is referred to as a typhoon. And if it develops over the region of northern region of Australia, it is referred to as Willy Willies. So this different name is depending upon where this phenomena is observed. But across the globe, you will observe that around the tropical regions, you have the formation of these kinds of cyclones. Now, not all or every low pressure will not lead to the development of a tropical cyclone. You have certain pre-required conditions which need to be fulfilled for a low pressure to be converted into a tropical cyclone. So first of all, you need large sea surface with a temperature higher than 27 degrees Celsius to create an intense low pressure. To create an intense low pressure. Then, presence of Coriolis force, very much essential to attain that anti-clockwise or the clockwise circulation of air in general. You need the Coriolis force. It is because of the lack of this Coriolis force that no cyclonic formation is observed around the region of equator. A small variation in vertical wind speed. What does this mean? This word basically means that the wind moving closer to the ground surface and the wind moving higher up, there should not be a great difference in speed, what is also referred to as wind shear, which basically means that the difference in speed of air closer to ground surface and speed of air at an elevation. So, this difference in between the speed of air near the ground surface and the speed of air higher up, this difference should be small. Why? Very good, Pranay. This should be small because imagine if you have a condition where you have a low pressure formed closer to the ground surface. Here, or the sea level, obviously. Now, here the speed, let's say, is 20 kilometer per hour. But the speed higher up, let's say, is 120 kilometer per hour. So any cloud formation which will happen, that cloud will be taken away. So the entire development of tropical cyclone will be vitiated, will be disturbed if you have a distinct difference in speed. So that is why if the speed is very common, very similar at a lower level and at a higher elevation, that means the entire disturbance, the entire low pressure circulation is allowed to develop quite significantly. Okay, and you also need a pre-existing weak low pressure area as well. So these are the requirements. If these conditionalities are fulfilled, only then will a low pressure get converted into an actual cyclonic circulation. Otherwise, sometimes you will observe a low pressure has developed, it has rained in that area, there is no cyclone. But sometimes it develops into a tropical cyclone. Now, before we move on here, because in general, majority of us face a problem in this. So, how many of us have an idea about latent heat of condensation? If we have an idea, let me know. I will launch a poll to get a better idea about it. How many of us have an idea about latent heat of condensation? Yes or no? This you would have studied in your class 6th, 7th or 8th science. So we have 50-50. Okay. Fair enough. So let us talk about briefly about latent heat of condensation. Or generally, let us talk about latent heat. What is latent heat? When we talk about latent heat, what is it? Latent means it is not something which is very apparent. It is something which is stored. So, it is the amount of heat released or absorbed when a particular material changes state from solid to liquid, liquid to gas, gas to liquid, liquid to solid. So, amount of heat released or absorbed when a material changes state. Its state. That is solid to liquid, to gas, or gas to solid, or rather to liquid to solid. So, for example, think about any state of matter. Let's consider water itself. Now, when water is in its solid form, it has got various different molecules, and these molecules are bound by each other with the help of various different bonds. Isn't it? Let's suppose this is solid. Now, if you apply heat to it, some amount of heat will be required in order to break these bonds, because heat is a form of energy. So that is where some amount of heat will be required to break the bonds. As the molecules, they start vibrating vigorously, these bonds will eventually be broken. And that is why, in order to get converted from solid to, let's say, a liquid state, where the particles are much more free flowing, they have weaker bonds, let's say liquid. So, in order to get converted from solid to liquid, some amount of heat is absorbed. Heat absorbed. Why is the heat absorbed? To break the bonds. Similarly, let's suppose we talk about gas, that is water vapor. Let's suppose vapor. Vapor is in gaseous state, so the molecules are very far away from each other. Now let's suppose this condenses into a liquid or into solid. Let's suppose it undergoes condensation into liquid or solid. Now there you will observe the development of bonds. Now for the development of these bonds, some amount of energy is released, because in order to break the bonds you need more energy, you absorb energy, but when you form those bonds, energy is released in the process. So in this process, heat is released. Heat is released. So whenever condensation takes place from vapor to solid or liquid, heat is released because of formation of bonds. That release of heat is referred to as latent heat of condensation. So here, whenever condensation takes place or condensation occurs, that is liquid vapor to liquid or solid, heat is released and that is latent heat of condensation. Condensation. Okay, so just understand this basic fact, if not the entirety of it, just understand this basic fact that in order to, let's say, convert a solid to liquid, heat is absorbed. That because you raise the temperature. In order to convert liquid to gas, again heat is absorbed. You have to raise the temperature to get converted into a gas. In order to convert gas to liquid, you need to cool it down. So you release heat for the conversion of the state. So that is the latent heat of condensation. Whenever water vapor that gets converted into a solid or a liquid, heat is released, that is latent heat of condensation. Here the temperature remains the same. The outside ambient temperature remains the same. Yes, Himanshu, that is correct. Now, Abhijit, wind shear, just wait for a couple of moments and it will be very clear what is this wind shear. Now we come to the main crux of the matter, and that is the formation of tropical cyclone. Now, this is one of those concepts, just like the case of temperate cyclone. In majority of the study materials, it always is given in such a confusing manner that eventually, rather than learning something, you end up losing your whatever concept that you have had. So that is why I would suggest to you, pay attention here itself. Try to understand the process of formation. Once you have understood the process of formation, why it is formed, then you will never forget it. We will cover the various different stages involved also. So let us talk about the process of formation, starting with the basics. That is, you have a very large water body. Let us assume Bay of Bengal. Now, in that large water body, you have a significant portion which heats up. A region heats up with a temperature exceeding 27 degrees Celsius. So when that region heats up, there will be development of a low pressure, a thermal low pressure, and observe it step by step along the way. That is where it is going to help you. Now, low pressure due to heating means what? In that region, immediately the air will initiate the rising up motion. Now, because this is a low pressure, winds will be attracted from all the different directions towards this low pressure. Winds will be attracted from all this different direction towards this low pressure. Now, as the winds come over this low pressure, they will also get heated up. They will also rise up. But will they rise up in a straight manner, or will they rise in a circular manner? What do you think? The winds which are coming in and then they are getting heated up, will they rise up in a straight manner, or will they rise up in a circular or a spiral manner? Perfect. It will be a spiral rise because of the Coriolis force, a spiral or a circular rise, very similar to the image that we saw in this case, where we saw this image here. So the wind is rising in a kind of a circular fashion, isn't it? Very similar to that. You will observe a characteristic very similar to that. So the winds, they will start rising in a circular fashion. They will start rising up in a circular fashion. Now, as they are rising up, what will happen to the wind temperature, the air temperature? The air temperature, will it remain the same, or will it fall down, or will it heat up? What do you think will happen to the air temperature? It will fall down, or it will rise up? Okay. So as the air rises up, it starts to lose temperature, because rising up means expansion, it will cool down. Now, as it is cooling down in the process, cooling down means the air will reach saturation, isn't it? Cooling down means the air will reach saturation. And after that, if it is still rising, means what? It will lead to cloud formation, a condensation will happen. Now, where will the condensation happen? If I ask you, or if I give you two different places, that there is a region in between here, let's name this as point 1, and there's a region, let's say point 2. As the air is rising, I hope you are able to see point 1 and point 2 on the image. So point 1 and point 2, out of these two places, point 1 is in between, point 2 is on the sides of that spiral. Out of point 1 and point 2, where do you think condensation will happen in general? What do you think? Beautiful. Very good. Condensation will happen where the air is moving. Air is moving along the sides. So condensation will happen wherever the air is moving. So always the condensation will happen across point 2, right? So always you will observe condensation will happen across the sides of it. So across the sides, you start observing the condensation all across the sides. Condensation will start to happen. And here also, you have vertical rise of wind almost. So which kind of cloud formation will you observe here? You will observe cumulonimbus clouds to be formed here. Very, very thick, very significant vertical development. This is the side profile of the clouds. If somehow you were to cut the clouds from between, this is how it will appear to look like. Why condensation occurs across the side? Aarti, take a look at it. Here, if I bring you back to this image, if you observe this image carefully, all of you, so condensation will happen wherever the air is present, or condensation will it happen in center? Always the condensation will happen across the sides where the air will lose the temperature, because in the center, in general, you don't have an air movement at all, right? So majority of the condensation will happen across the sides of it. Here, the cloud development will also happen across the sides of it. There are other reasons also why condensation will happen on the sides. We'll come to it. Now, as the condensation is happening, during condensation, what happens? During this condensation, in the center, you have latent heat, which is released. Whenever condensation happens, due to condensation, what is observed? Latent heat is released. Now, if the latent heat is released, now the clouds are being formed on the sides of that rising air. So latent heat will be released in the central portion. Now in the central portion, the temperature goes up. As the temperature goes up in the central portion, means what? No saturation, no cloud formation, because for all of this, you need lower temperatures, but latent heat is being released in the central position here. So no cloud formation in the center. Now, if ever you have basically, you would have done that, I'm sure, at some point of time in your life or other, even though now we act all mature and grown up, but I'm sure at some point of time you have done this, that you have a bucket or a drum or any large storage of water. Have you ever tried to swirl it around by your finger, by your hand, or by any stick? I'm sure you would have done that, right? If you take a bucket of water, let's suppose, give it a swirl on the sides and continue to do it as long as it takes to have that circular motion in the water itself. I'm sure you would have done that, right? So when you do that, the level of water on the side starts to come up as the water develops that circular motion. What happens to the water level at the center? At the center of the bucket. If let's say this is the bucket of water, let's say if this is the bucket of water, and all around the sides you have given it a swirl, what happens to the water level at this area? Will it remain undisturbed? Will it go up? Will it go down? What is it that you have experienced? The water level. Very good. The water level in the central position generally goes down. Why? Because there is a significant circular motion restricted in that area that develops a kind of a whirlpool-like motion which pulls the central portion downwards. Now, this is how the fluid behaves. Air, as I told you in the initial stages itself, air also is very similar in terms of the fluidic motion that you have. So air, in this case, restricted by the clouds all around as it rises up, it behaves almost in a similar fashion. So what will happen to the air in the central portion? The air in the central portion, that is sucked downwards. That is something which is pulled down. So here, the air in the central portion, that starts going down. Now, as the air starts going down, it is moving into an area where the air density is higher. So it undergoes adiabatic compression. Some amount of heating will be observed. So this air, as it ventures down further, it heats up. This is heating of sinking air. Why? Due to adiabatic heating or adiabatic compression. Due to a significant level of adiabatic compression, the central portion starts to heat up. To add to that, all the latent heat which is being supplied in the central portion, all that latent heat will further heat the air down. Now that heated air, what will it do? It will heat up the low pressure furthermore. The low pressure gets further heated up, means the low pressure intensifies. So as a consequence of this, low pressure intensifies. Low pressure intensifies means what? You have more winds which will be attracted towards that low pressure. Now more winds will be attracted, and these winds are coming from the oceanic areas, the water bodies. So they will carry much more amount of moisture. Significant amount of moisture will be carried out. Now this air, when it reaches that low pressure, it will also get warmed up, rise up. Very soon it will form clouds because it is moisture laden. More clouds formed means more latent heat of condensation, means what? More intensification of low pressure around the center, means what? More attraction of moist winds. So this is a self-feeding cycle that is generated. So once the latent heat is released, eventually, due to sinking air, you have intensification of low pressure. Significant intensification of the low pressure. And when you have a significant intensification of low pressure, that means what? More winds, moist winds are attracted. Why moist? Because it is formed over a water body. More moist winds are attracted. When you have more moist winds which are attracted, that means what? There will be greater condensation. Greater Greater condensation means more latent heat will be released. And this is a self-feeding cycle. And this is what leads to intensification of cyclone. And this is one of the properties by which the tropical cyclone can keep feeding it on itself and can keep on getting stronger. So, this is intensification. Intensification of cyclones. So you have a significant bit of intensification of cyclones which will happen, and the cyclones keep on getting stronger. This is where, had it been over a land area, let's suppose this low pressure had been over a land area. Now that would also have attracted winds, but it would not have contained so much amount of moisture that it would lead to condensation happening on a regular basis. So that is why this feedback loop would not have been initiated had this been formed over a land region. That is why tropical cyclones will develop only over water bodies. Regardless of how warm or how hot the land area becomes, it will develop a low pressure, it will cause rainfall, but it will not develop into a cyclone. A self-feeding mechanism, a self-intensification mechanism can be initiated only when you have very moist and warm winds coming over that low pressure, rising up, carrying out that kind of condensation. It is because of this that this particular region or a tropical cyclone is also able to generate heat itself. It is the heat generated here is by the process of the latent heat which is released, as well as that latent heat further fueling up more rise of air, further fueling up more latent heat. And that is why tropical cyclones, many of the times, they are also referred to as heat engines for their ability to generate heat on itself, right? Has the ability to generate heat by itself, as long as it is over a water body. So that means the longer the cyclonic circulation or disturbance, longer the time period that it stays above the water, greater will be the amount of heating which will be observed. Okay, greater the time period that it spends over the region of a water body, greater will be the amount of intensification of that cyclone. So the cyclone tends to get much more stronger over that time period. Always understand that as long as it is over a water body, it will continue to get stronger. The moment it hits any kind of landmass, that is when it loses its connect with that moisture. That is when this latent heat that is disrupted, and that is when eventually it will dissipate. As long as it is over a water body, it will continue to get much more stronger. Okay, so this central portion, that is referred to as the eye of the cyclone. And this is referred to as eye wall, the sides of it. Now, in the case when we say eye of a cyclone, so here, no cloud formation, no cloud formation. Here, sinking air. sinking air column. And also in this region, you will also come across another factor, that is clear sky. Generally higher temperature. Higher temperature as compared to the surrounding areas. Okay. So as compared to the surrounding areas, the temperature will be generally on the higher end. Okay. So that is the formation in the case of a tropical cyclone. Now, as soon as, let's suppose, it hits a landmass, this entire system, let's say, is traveling and it hits the landmass. Now, in that case, first of all, for an individual who is standing on the land observing this movement, for that individual, initially what they will observe is that you have significant amount of rainfall caused by all these clouds, very strong wind movement, the eye wall, along with heavy rainfall, thunder, lightning, because you have cumulonimbus clouds which are created, which are formed here. So it will bring very violent condition. But then the eye comes over. When the eye comes over, that is when you have clear sky, no formation of rainfall, no cloud formation. So everything appears to be hunky-dory and calm. And immediately that is when people mistake it to be the end of the cyclone, but it is not so. It is not the end of the cyclone. Because then after the eye follows the other branch of the cyclone, the other end of the cyclone, which is equally more dangerous. So once the eye finally makes the landfall, that is when its supply to the moisture, that is cut off. And that is when the cyclone begins to dissipate. So this tropical cyclone, it will start dissipation starts as the eye hits the land, makes landfall. So when the eye makes landfall means no rainfall, clear sky, no cloud. So at this point of time, supply of moisture gets to the circulation, gets cut off. When the supply of moisture to the circulation gets cut off, it is at this stage where no, or rather dissipation or weakening is initiated. This is what the cyclone appears to look like from above. This is what is the eye of the cyclone. And this is what the eye wall is. Okay. So when that entire thing makes a landfall, that is when you have a significant amount of destruction and disturbance on the ground surface. That is the process of formation. I will do one thing. I will repeat the entire process from the very initial stage. Try to understand it. Then if you have any doubts, feel free to ask it as of now, because get it clear here. And at this point of time, you won't be required to go through the voluminous notes and various different study materials later on, which will only end up confusing you. So let's understand it again from the ground up, from the very basic. So initially, for the formation of this cyclone, you do require a very warm water, tropical water, generally an ocean or a sea. When the temperature is exceeding 27 degrees Celsius, that is when a distinct thermal low pressure starts to develop on the water body. Now, when a distinct low pressure develops over the water body, that means what? It will attract winds from various different directions, from all the different directions. Now, the air, when it comes over to that low pressure by this point of time, because it is a water body, the air will have significant amount of moisture associated, very large amount of moisture. Now this air, when it comes over that low pressure, it also gets heated up. It also warms up and it starts rising up in a spiral manner owing to the Coriolis force. Now, as it rises in a spiral manner, eventually after a height of even 2 kilometers or furthermore, because it is moisture laden, that is when condensation will happen. And condensation happens generally across the airflow, where the air is losing temperature. So as the air, let's say, is moving here, some condensation will happen here, some will here, some happens here, and so on. The condensation happens all across the sides of it. Imagine, again, I will take the help of that piece of paper. Imagine that this piece of paper represents the circular rise. This cylindrical piece represents a circular rise. All around it, the air is rising up. So condensation will happen here, 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 all around the sides. The condensation will keep on happening. As the condensation is happening, heat is released. Why? Because the vapor is changing state. So latent heat of condensation is released in the central portion. Now, the central portion has got the presence of sinking air or subsiding air column. This is where you have sinking air. Sinking air. That is because of what? Because of the circular motion, a vigorous circular rise of the air. Why a vigorous circular rise? Because already the air is warm. Plus the water body is heated up. So immediately that thermal low will create a vigorous rise. So all around it, as it is rising in circular motion, in the central portion, you will have a subsiding air column or a sinking air column. That sinking air column heats up eventually because of adiabatic compression as it reaches closer to the ground surface. This sinking air column, meanwhile, it will gain all the heat, and that is the latent heat, which is continuously being released as soon as cooling happens or condensation happens. That latent heat is being released. So that sinking air column, which further heats up by the time it reaches the surface, it will intensify the low pressure. The low pressure, when it becomes more intense, means what? It will attract more winds from the sides. More winds are attracted from the sides means what? These are moist winds, moisture carrying winds, because these are coming over the water bodies. So more moisture means more condensation, means more latent heat will be released. So it is a self-fueling cycle. And that self-fueling cycle is able to generate heat on its own. It no longer requires the availability of solar insolation and other heat. No. Despite maybe the sun being blocked out, it is able to generate heat on its own because of that phenomena of rising air, subsiding air, as well as the latent heat of condensation. That is why it is also referred to as a heat engine. And this is when eventually the development and strengthening of the cyclone takes place. If this entire process would have formed over a land area, you would not have had the supply of this much amount of moisture. So this much amount of condensation would not have happened. If condensation would not have happened, latent heat would not have been released. Intensification of low pressure would not have happened. So that is why it can happen only over a water body. And that is why a tropical cyclone develops over a water body. So in the central portion, where you have a sinking or a subsiding air, no clouds, because for cloud formation you need rising air. So no cloud formation, higher temperature, because of all the accumulation of latent heat from the surrounding eye wall, and also clear sky. Now, when that entire phenomena makes a landfall, that is when the supply to moisture gets cut off. That is when the cyclone starts to weaken, it starts to dissipate. Now, if you understand the process of formation, then you take a look back at the conditions required for the cyclonic formation. Large sea surface with temperature higher than 27 degrees C, very essential for the supply of moisture. Presence of Coriolis force, very essential to attain that circular spiral rising motion. Small variation in vertical wind speed or wind shear. Imagine if the movement of wind near the ground surface would have been weaker, much weaker, and the movement of wind upper, higher up, would have been very strong. All the clouds would have been taken away. Latent heat of condensation would not have been restricted to a smaller area. That is why you need a very small difference in wind speed at different heights, so that the entire circulation is allowed to develop. Okay, so this is how a tropical cyclone generally is developed. Okay, now whatever are the doubts, feel free to ask in the process of formation, or if you have understood that, please confirm the same as well. Does temperate cyclone originate on land? Temperate cyclone can originate both over land as well as water body, because it is due to formation of a front, whereas tropical cyclone will always develop only over water bodies. Why sinking of air doesn't create high pressure in the center? Because here, that sinking air, Nitin, what is being observed, that heats up further. And this is already a thermal low pressure, that large thermal low pressure zone. In between, you have small sinking, which is done due to that heating, which intensifies the low pressure. So in the central portion, higher up, you can experience that high pressure. If you have to think about it, maybe here you can experience a high pressure because of sinking. Here, in general, because by the time that air reaches here, it has heated up in that restricted area, it intensifies the low pressure. Okay, intense basically, Anshu, means something which gets stronger. And Aarti, tropical cyclone dissipate when eye of the cyclone hits the land? Yes, it starts dissipating. It does not immediately vanish. It starts to weaken by that point of time. Are the points clear? How latent heat is intensifying? Latent heat is not intensifying. Latent heat is consistent. Whenever condensation is happening, latent heat will be released. That latent heat will continue to raise the temperature of the central portion in general. Of the central portion, the temperature will start to increase. And that is where the sinking air will bring that higher temperature. It will further intensify the heating of that low pressure. So that is where the sinking or the latent heat, it continues to maintain this cycle. Intensification of low pressure, more winds are attracted. So that is something which is observed. Sinking air comes from the surrounding regions. That is correct. Where will the sinking air end up? It will end up on the surface. Why the sinking air not have force significantly? Because by the time that it reaches the ground surface, it becomes so very hot, it becomes a medium to heat up the air around that region here. Okay. Any example of local wind? Wind shear, my dear friend, is basically the difference in wind speed that you have. That is what is a shear, right? So wind shear can be created by any of the local winds. Any local wind that you consider Chinook, consider Fohn, consider Lu. Any of the local winds when they are moving, if they are creating a difference in terms of the high altitude movement and the low altitude wind movement, it will develop a wind shear. Sinking air heat the surface of the ocean, that's more wind comes to that region. Yes. Okay. Is that I'm happy recently UPSC CDS asked features of cumulonimbus clouds. I solved. See, if you attend these sessions where we are elevating the concepts, CDS, etc., you will be able to solve very easily if you have understood the concepts that we are teaching in the class. But good to know, Pranay, that it has helped you. Okay, so can we move further? Right? Is that understood, or is there any discrepancy left here and there? Let me know. Understood. Okay. So now, after this, we come to the portion of the impact of these tropical cyclones. Basically, whenever these tropical cyclones they come over, generally in the coastal areas, you would observe that there is significant amount of flooding which is caused. A lot of floods are caused in the process, right, in the coastal areas. Now those are referred to as storm surges. Surge means a rise of something. Now, when the strong winds are driven by these cyclones, these strong winds also manage to pick up significant amount of oceanic water, because winds in general do what? So if this is the land area, let's suppose this is the sea surface. So as the winds they keep on moving, they will drive some amount of wave motion here. But let's say this wind suddenly becomes very, very strong. It will carry enough water along with it, and that water will hit the coastline. So when you have very strong winds, observe that significant amount of water is carried over, dropped over the coastline, due to which the coastal regions oftentimes they get flooded. And that is what is referred to as a storm surge. It is an abnormal rise of water generated by a storm over and above the predicted tides. So generated by a storm means very strong winds. When you have very strong wind motion or wind movement, this is something which is observed, which is experienced. Now, after this, in this also high pressure and low pressure concept will be applied. Where, in what portion, Utkarsh, high pressure and low pressure concept? Generally, the cyclonic formation will be due to the low pressure creation. Otherwise, cyclonic formation won't be there. Storm surge, when we talk about it, so any cyclonic circulation will have wind movement associated with it. And that wind movement, the strong wind movement, that is the strong wind movement that you observe when the cyclone hits. So that wind movement is able to create a storm surge. Okay? So very strong winds associated with cyclonic circulation. Okay. Now, here we come to the portion of how is it that the cyclones are named, or the naming of the cyclone. So earlier, cyclones would be named and they would be given a kind of a scientific name generally, a kind of a mixture of alphabet as well as numerics that was used to name the cyclones, but that would generally be for the meteorologist and the climatologist to have a reference about. A very harsh lesson was learned in 1999 when you had the disaster in Odisha. I'm sure majority of you would have absolutely no clue that what happened in 1999. You would have heard about from your parents, from your elders, from the older generation. If you can ask them, do ask them, especially those belonging from the region of Odisha, Andhra Pradesh, you would never forget, or those families would never forget, the destruction caused in 1999. So in 1999, what happened was that you had the development of a super cyclone. Cyclones are oftentimes classified based upon the velocity that the winds will take. Sometimes the winds are very, very strong. If the wind speed is expected to be greater than 200 and 220 kilometer per hour, then a cyclone is classified as a super cyclone. That means the chances of destruction and devastation, they are very, very high. So in 1999, a super cyclone was developing off the coast of Odisha. A warning was issued by the meteorological department, by the government. Now, obviously, at that point of time, mobile telecommunication was not developed significantly. You had significant amount of issues when it comes to administrative efficiency as well. People were asked, people were requested to basically evacuate their houses, go to a safer region at an uphill area which will not get flooded. Otherwise, cyclones, they generally bring about a lot of flooding because of immense rainfall and also storm surges. Now, generally, when someone from the government comes to your house and tells you to evacuate along with your belongings, you have a kind of a suspicion that something wrong might be there, right? They will somehow manage to take my house. If someone else comes, you might trust them, but the trust in government is very less. Imagine if it is less now. Imagine the situation in 1999. It was very, very limited. Now, in 1999, obviously, few people managed to evacuate, few people followed the governmental orders. In many of the areas, the governmental orders could not even reach in Odisha. The cyclone struck. It caused a lot of devastation. Many people, they lost their lives. Significantly large number of people lost their lives. There was a huge amount of criticism mounted on the government that it is because of your inaction, it is because of your inability to declare when the cyclone is going to strike. That is why so many people lost their lives. Now, obviously, government is to blame, and the government is blamed for virtually anything and everything. That is also justified because people had lost their lives, people had lost their houses, and the loved ones who are never going to come back again. So there was a lot of anger. Meanwhile, the meteorological department observed, while the people were still grappling with the losses happened in Odisha. Meanwhile, meteorological department observed that in the region of Bay of Bengal, there has been significant heating and there is a simultaneous development of another very strong cyclone, which is going to hit Odisha again within 10 days. Now, this time, the government, smarting from the earlier action, the government this time was very active. The government started announcing, doing everything that it could. State government, central government, everybody took part in it. And they started announcing everywhere that a cyclone is about to hit, take shelter, evacuate. But this time, the perception was that look at them. The cyclone has already struck, destroyed us, and now they are coming with the announcement. The typical mentality or the typical understanding or assumption is what? That the government is late. The cyclone which has already passed, they are announcing for that cyclone. But little did people know that a new cyclone is about to come because they never had experienced this kind of frequency of cyclones. Within a week, another cyclone struck. And this time, many people were unaware. Many people were out on the streets searching for their loved ones, getting their properties, getting their things together from the flooded areas when another cyclone struck. And many people lost their lives. In total, it is estimated that anywhere close to 15 to 20,000 people, they lost their lives within the span of 15 days in Odisha. The region of Cuttack Puri, Bhubaneswar even, all these areas were completely devastated. It was the image of it, if you can search from Google at that point of time, image of it is akin to a kind of a war-torn territory. Everything is flattened. There was flood all across, bodies floating around. It was a disastrous sight to beckon with. It is at this point of time when there was a realization. The realization was, first of all, we need to get a prediction in a timely manner. And secondly, we need to name the cyclones so that people don't get confused. And that is when the entire aspect of naming of cyclones that began. Now in 2000, 8 different countries around the region of northern Indian Ocean who are impacted by the cyclones, they got together. These 8 countries, all of them, they submitted 8 names. One by one, the names were picked up and the cyclones started being named. Eventually, that final name on that list was Ampan. The cyclone, which was named Ampan, actually occurred in around May, the last week of April and first week of May in 2020. And people already were aware that the naming list is coming to an end. That is when, around 2018-19, 13 countries in the northern Indian Ocean, all of them, they came together. And this time, all of them submitted 13 names. So in total, now you have 169 names. One by one, that name is picked up and the cyclones are named. So that is how naming is done. Initially, what is done is the Tropical Cyclone Warning Center, it warns the regional meteorological center that look, a low pressure depression is getting created. This low pressure depression can intensify into a cyclone. Now, once the regional specialized meteorological center gets an idea that a cyclone is developing, they pick a name from that list and they give that name to that cyclone. And that is how eventually the naming is done. Across the entirety of the world, you have 6 different RSMCs. RSMC Miami for naming of the hurricanes, RSMC Honolulu, RSMC Tokyo, Nadi, Reunion Islands, and also RSMC New Delhi. Every cyclone which occurs in the northern Indian Ocean, be it the Arabian Sea, be it the Bay of Bengal, they are named by RSMC New Delhi, Regional Specialized Meteorological Center, New Delhi, which has got its office in the Indian Meteorological Department building itself in New Delhi. They pick a name of that list. What is that list? So the list overall, if you observe, these are your 13 countries. And all these 13 countries, they are arranged in an alphabetical manner. Arranged. So Bangladesh, India, Iran, Maldives, Myanmar, Oman, Pakistan, Qatar, Saudi Arabia, Sri Lanka, Thailand, UAE, and Yemen. These are your 13 countries. And the names that they have given, they are arranged in rows in front of them. So accordingly, you have 13 columns. One by one, the name is picked up. Now, the latest cyclone which is getting formed, that has been named Mocha. Before that, whether it is in Arabian Sea or Bay of Bengal, Mandus. Before that, Sitrang. Now, after Mocha, whether a cyclone will be created in Bay of Bengal or Arabian Sea, it will be named Biparjoy. After Biparjoy, if a cyclone is created in Bay of Bengal or Arabian Sea, it will be referred to as Tej. After Tej, whether in Arabian Sea or Bay of Bengal, Hamoon. So that is how eventually the naming is done. One by one, the name is picked up from the list and the cyclone is given the name. So as of now, Mocha is developing over the region of Bay of Bengal. Okay, so this is about the naming of the cyclone, and this is basically the difference in between the tropical and the temperate cyclones in general. Tropical cyclones move from east to west, temperate cyclones they move from west to east because of trade winds in the case of tropical cyclones, because of westerlies in the case of temperate cyclones. Tropical cyclone formed over a comparatively smaller area. This has to be formed temperate cyclones. They are formed across a front, so a very large area. Velocity of wind in tropical cyclone is very high, very damaging. Velocity of air is comparatively low because it is a dynamic pressure rather than a thermal pressure. Thermal pressure generally is associated with very strong wind movement. Tropical cyclone forms only on seas with temperature more than 27 degrees Celsius and dissipates when it reaches the land. Temperate cyclone can be formed both over sea as well as land. Tropical cyclone doesn't last for more than 7 days because it will make a landfall, it will dissipate. Temperate cyclonic condition can extend for 2 to 3 weeks. So this is the difference, and that is the aspect of tropical and temperate cyclones. Tropical cyclones are thermal. Yes, Utkarsh, that is correct. Okay. So that is where we finish this particular chapter and we take a break. After that break, we come to the portion of the atmospheric phenomena and then we will move ahead. So we take a lunch break here, guys, and we take a break for 40 minutes. So here we will be taking a break till 3:50. Okay, break till 3:50. And then we will be talking about the various atmospheric phenomena like El Nino, La Nina conditions, jet streams, and so on. Okay, let's take a break now.